In this lesson, we're going to discuss chemical reactions and the law of conservation of mass. We've already done one lab here in Science 10 that has supported the law of conservation of mass. The law of conservation of mass states that in a chemical reaction, the mass of the reactants is equal to the mass of the products. Therefore, we can infer that the number of atoms of each element in the reactants must be equal to the number of atoms of each element in the products. Because of this, we need to make sure chemical equations which describe chemical reactions are balanced. So in a chemical equation, we use coefficients to balance the number of atoms of each element in both the reactant and product side of a chemical equation. In a chemical equation, we must use coefficients. We cannot change the subscript, but rather must put coefficients in front of each element or compound to balance the number of atoms of each element. So to learn how to balance chemical equations, you must first be able to count atoms. So let's look at example 1. Here we have 3 particles, if you will, of hydrogen sulfate, or otherwise known as sulfuric acid. So in this example, we can see that there are 3 times 2, so 6 hydrogen atoms, 3 times 1 sulfur atom, and 3 times 4, which gives 12 oxygen atoms. So we multiply the coefficient by the subscripts to determine the number of atoms of each element. In example 2, if we have 5 calcium phosphates, we multiply 5 times 3 to give us 15 calcium atoms, 5 times 1 times 2 to give us 10 phosphorus atoms, and 5 times 4 times 2, which would give us 40 oxygen atoms. So this is the first step that must be done in order to balance chemical equations. So we need to be able to work from word equations to end up with balanced chemical equations. So let's look at an example to see how this is done. So the word equation is this. Sodium metal reacts with chlorine gas to produce sodium chloride. So step 1 is to write formulas for the elements and compounds in the word equation. So in this case we have sodium metal represented by Na. Chlorine gas is a diatomic molecule, one of the Brinkelhoff atoms. So it always exists as Cl2 to give us sodium chloride. So in this step, to balance the chemical equation, we will count the atoms on the reactant side and the product side, and place coefficients in front of the symbols as needed to balance the chemical equation. So from this, we can see what we call our skeleton equation here. If we look at it, on the left-hand side, or the reactant side, we have 1 sodium atom and 2 chlorine atoms. On the product side, we have 1 sodium atom and 1 chlorine atom. So we can see right away that this isn't balanced. So balancing quite often is just a trial and error, at least that's one way of looking at it. So what we can try to do is place coefficients in different locations to balance the chemical equation. And so here we can see that we actually have the chlorine being out of balance. So if I wanted to, I could place a coefficient there in front of the NaCl to balance the chlorines, and that throws our sodium out of balance. So all I need to do is place a 2 in front of the sodium to have the balanced chemical equation, and I can check at the end by counting my number of atoms of each. So I have 2 sodiums and 2 chlorines on the left side, and 2 sodiums and 2 chlorines on the right side. So the chemical equation is now balanced. Let's look at a couple more examples, and you have to bear with me here for my messy writing. But let's look at what we have here. So we have magnesium chloride reacting with sodium sulfide to produce magnesium sulfide and sodium chloride. So the first step is to write down the chemical formulas. So magnesium chloride would be MgCl2 reacting with sodium sulfide, which is Na2S, and that would produce magnesium sulfide, which is MgS, and sodium chloride, which is Na. Hopefully I don't run out of room, Cl here. So often this is a little bit of trial and error here, but I can see from this chemical equation that my sodiums are out of balance. So if I place a 2 in front of the sodium on the right hand side, I now have 2 sodiums and 2 chlorine. And if I look at the other atoms and just give it a count through, I can see that my sodiums are now balanced. I have one sulfur on the reactant side and one sulfur on the product side, so my sulfurs are balanced. I have one magnesium on the left side and one on the product side of the equation, so my magnesiums are balanced, and I have two chlorines and two chlorines. So actually this ends up being a relatively straightforward chemical equation to balance. Let's look at one final example here. So in this example I have iron reacting with oxygen gas to produce iron 3 oxide. So I'm going to write down my equation. So I have iron, which is Fe, getting very messy here. Oxygen gas is diatomic, oxygen is diatomic, so I got Fe plus O2 produces iron 3 oxide. So iron 3 oxide is Fe2O3. So this looks like it might present a bit of a challenge. And again, forgive my messy writing here. So I have 3 oxygens on the right hand side and 2 oxygens on the left hand side of the reactant side. So if I just deal with the oxygens first, I need to figure out what's the lowest number of oxygen atoms I can balance them at. So I look at 3 and 2, and both of those go into 6. So the lowest number of oxygen atoms I can have is 6. So let's try to do that. So if I put a 2 in front of the iron 3 oxide, I now have 2 times 3 gives me 6 oxygen atoms, and 2 times 2 gives me 4 iron atoms. So I need to place a 4 on the left hand side of the equation, and I now have my balanced chemical equation. So that's a quick introduction into balancing chemical equations. I hope this lesson has helped you, and I'll try to put up a few more examples of working through some balancing chemical equations over the next little while here.